Alpine Linux is a lightweight, security-focused Linux distribution that was designed with simplicity, efficiency, and correctness at its core. Unlike many mainstream distributions that aim to be all-encompassing desktop operating systems, Alpine Linux was built with a very specific philosophy: keep everything minimal, predictable, and secure while still being powerful enough to run modern workloads. To truly understand Alpine Linux, you need to understand why it exists, how it differs from traditional Linux distributions, and why it has become so important in areas like containers, servers, and embedded systems. At its foundation, Alpine Linux uses musl instead of the more common EUC library, also known as glibc. This single design decision already sets Alpine apart from the majority of Linux distributions. Musl is designed to be lightweight, standards-compliant, and secure. It has a much smaller codebase than glibc, which reduces the attack surface and makes it easier to audit and maintain. Because musl focuses on correctness and simplicity, many subtle bugs and inconsistencies that exist in glibc simply do not exist in musl. The trade-off is that some software written with assumptions specific to glibc may not work out of the box on Alpine. This has historically been one of the biggest learning curves for users new to Alpine Linux, but it is also one of the reasons Alpine is so robust and predictable in production environments. Another core component of Alpine Linux is BusyBox. BusyBox replaces many traditional ENU utilities with a single binary that provides simplified versions of common commands like ls, cpgrep, and mount. This drastically reduces disk usage and memory footprint. While these utilities may not support every advanced option found in their new counterparts, they cover the vast majority of real-world use cases. For servers, containers, and embedded devices, this trade-off is more than acceptable. In fact, it is often desirable because it reduces complexity and removes unnecessary features that could introduce bugs or security issues. Security is one of Alpine Linux's strongest selling points. The distribution was built with security as a first-class concern rather than an afterthought. Alpine uses position-independent executables by default, which allows for full address space layout randomization. This makes many types of memory-based attacks significantly harder to exploit. Stack smashing protection, hardened toolchains, and minimal default services are also standard. On a fresh Alpine installation, very little is running by default. This is the opposite of many general-purpose distributions, which often start multiple background services, even if you never use them. In Alpine, you explicitly enable what you need and nothing more. The package manager in Alpine Linux is called apk, short for Alpine Package Keeper. APK is intentionally simple and fast. It uses plain text configuration files and a straightforward command syntax. Installing, removing, and upgrading packages is typically faster than on heavier distributions because the packages themselves are smaller and have fewer dependencies. Alpine packages are designed to be modular, meaning optional features are often split into separate packages. This allows you to install only the exact functionality you need, rather than pulling in a large dependency tree by default. Alpine Linux also uses OpenRC as its init system instead of systemed. This choice aligns with Alpine's philosophy of simplicity and transparency. OpenRC uses shell scripts for service management, which makes it easy to understand what a service is doing and how it is started. There is no central binary controlling the entire system. Services are grouped into run levels, and the boot process is straightforward and easy to customize. While systemed offers powerful features and tight integration, it is also complex and opaque to many users. Alpine deliberately avoids that complexity. One of the most common places you will encounter Alpine Linux today is in container environments. Alpine has become the default base image for many Docker containers because of its extremely small size. A minimal Alpine image can be as small as a few megabytes, compared to hundreds of megabytes for more traditional distributions. This has enormous implications for container startup time, network transfer, and security. Smaller images mean faster deployments and fewer packages that could potentially contain vulnerabilities. When you base a container on Alpine, you start with almost nothing and add only what your application needs. However, Alpine's use of musl means that some precompiled binaries built for glib-based distributions will not run on Alpine without modification. This is why some developers initially struggle when moving their applications to Alpine-based containers. In many cases, the solution is simply to compile the software against musl or use Alpine's package repositories, which already provide musl-compatible builds. In other cases, especially with proprietary software, this can be a real limitation. Despite this, the benefits of Alpine's minimalism often outweigh the inconvenience, especially in cloud-native environments. Alpine Linux is also popular in embedded systems and appliances. Its small footprint and predictable behavior make it ideal for routers, firewalls, and specialized devices. Because Alpine can run entirely from RAM and use read-only root file systems, it is well suited for environments where reliability is critical. Updates can be applied by replacing the entire system image, reducing the risk of partial upgrades or configuration drift. This immutable style approach, while not exclusive to Alpine, is very natural within its design. From a user experience perspective, Alpine Linux can feel very different from mainstream desktop distributions. There is no graphical installer by default, and the base system boots to a command line interface. Configuration is done manually through text files and setup scripts. This can be intimidating for beginners, but it also provides a level of control and understanding that is often missing in more automated systems. Alpine does not try to guess what you want. It expects you to know or to learn. Despite its minimalism, Alpine Linux is not limited to servers or containers. It can be used as a desktop operating system, although this is a niche use case. With some effort, you can install a graphical environment, a display manager, and all the applications you need for daily use. The result is an extremely fast and responsive system with low resource usage. However, users must be prepared to troubleshoot compatibility issues and configure things manually. Alpine's strength is not convenience, but clarity and efficiency. Another important aspect of Alpine Linux is its release model. Alpine follows a stable release cycle with long-term support versions. Packages are generally conservative, prioritizing stability and security over the latest features. At the same time, Alpine maintains edge repositories for users who want newer software. This dual approach allows Alpine to serve both production environments that require stability and developers who want access to more recent versions of tools. The Alpine community is relatively small compared to giants like Ubuntu or Fedora, but it is highly focused and technically competent. Documentation is concise and to the point. The Alpine Wiki is an invaluable resource, especially for understanding how to configure the system properly. Because Alpine avoids unnecessary abstraction, troubleshooting often involves reading simple shell scripts or configuration files rather than digging through layers of tooling. One of the most interesting things about Alpine Linux is how it challenges assumptions about what a Linux system needs to be. Many users are accustomed to large-based systems with countless utilities, background services, and dependencies. Alpine demonstrates that a fully functional Linux system can be incredibly small and still meet modern demands. This is especially relevant in an era where efficiency, security, and scalability matter more than ever. Performance is another area where Alpine Linux shines. With fewer running services, smaller binaries, and less memory overhead, Alpine systems often feel faster and more responsive than their heavier counterparts. This is not because Alpine uses magical optimizations, but because it simply does less. There is less to load, less to manage, and less to go wrong. In high-density environments like container clusters, these small efficiencies add up to significant gains. Alpine Linux also encourages a different mindset when it comes to system administration. Instead of relying on large frameworks and automated tools, Alpine pushes you to understand the basics: how services start, how networking is configured, how file systems are mounted. This can be refreshing for experienced users who feel overwhelmed by modern Linux complexity. It can also be educational for newcomers who want to learn how Linux really works under the hood. That said, Alpine Linux is not a universal solution. It is not the best choice for every scenario. If you rely heavily on proprietary software or precompiled binaries that expect glibc, you may encounter friction. If you want a system that works out of the box with minimal configuration, Alpine may feel unfriendly. The learning curve is real, and Alpine does not try to hide it. But for users who value control, transparency, and efficiency, this is a feature rather than a drawback. Over the years, Alpine Linux has quietly become one of the most influential Linux distributions. Despite its relatively low profile, its impact on container ecosystems alone is enormous. Many developers use Alpine daily without even realizing it, because it runs inside their containers rather than on their desktops. This behind-the-scenes role fits Alpine perfectly. It is not flashy, but it is reliable, efficient, and focused. In many ways, Alpine Linux represents a return to Unix-like principles. Do one thing well. Keep systems simple. Avoid unnecessary complexity. Make everything explicit. These ideas are not new, but they are often forgotten in modern software development. Alpine reminds us that simplicity is not about removing features, but about designing systems that are easy to understand and reason about. When you strip away the marketing, the installer graphics, and the desktop environments, what remains is the core of an operating system: a kernel, a libc, a set of tools, and a philosophy. Alpine Linux is very clear about its philosophy, and every technical decision supports it. This coherence is rare, and it is one of the reasons Alpine has earned such respect among engineers. Ultimately, Alpine Linux is best understood not as a competitor to mainstream desktop distributions, but as a specialized tool that excels in specific domains. It is a distribution for people who care deeply about how their systems are built and how they behave. It rewards curiosity, patience, and a willingness to learn. In a world of increasingly complex software stacks, Alpine Linux stands as proof that smaller, simpler systems are not only possible, but often better. By choosing Alpine Linux, you are choosing a different way of thinking about Linux. You are choosing explicit configuration over automation, minimalism over abundance, and security over convenience. For some, this will feel like unnecessary effort. For others, it will feel like finally being in control. That is the essence of Alpine Linux. A small system with big ideas, quietly powering much of the modern infrastructure while asking very little in return.